Hi everybody, welcome back. We only just have a couple videos for today, so we're going to talk about logarithmic properties. So we have two more simplification ones here. Is that log base b of 1 is always 0 and log base b of b is 1. And that simply follows from the fact that b to the 0 always equals 1 and b to the first always equals b when b is not 0 or not 1 and b is greater than 0. So that's a property that all exponential functions have, and this is just their logarithmic equivalent forms here. So really I want to talk about these solving properties here. So in particular I want to talk about the first two here, and then basically what number 3 says is logarithm is a new operation we can do to both sides of the equation, just like adding, subtracting, multiplying, dividing. And you could take the log of both sides, and so if you have m equals n, you could just take the log of both sides and get that. Sometimes it's advantageous to do that, and we'll see that in the next couple of videos when we start solving things. So let's talk mostly about these two properties. So let's let f of x be b to the x, and g of x be its inverse, log base b of x. Now, since these are inverses, we know from a previous section where we studied inverses that f circle g of x is going to be equal to x, and g circle f is going to be equal to x. And the idea here is we need to figure out what these two things are. So if we figure out f circle g of x, well, that's going to be fgx. Then we replace g of x with what it's defined to be. So this is f evaluated at log base b of x, and then f puts that expression into the exponent of an exponential function. And notice that since this equals x, this is just property 2 here. Doing the other way, we know that x is equal to g circle f of x. And so this is going to be equal to, let me see, g, f, and x. So we'll do our pattern there. Put in f, and we'll get g evaluated at b to the x. And then g is the logarithmic function, so we're going to take log base b of b to the x. And notice now that we get property 1. So that's really what property 1 and 2 here for the solving properties are. And the reason why this is important is because a lot of times you'll have a variable inside a logarithm or exponential function. So properties 1 and 2 tell you how to get rid of a variable that's in those kind of inconvenient places. And we'll see that with the next couple of videos here. So we're going to move on to the next video, and I'll see you then.